Question number 12. A math test has 25 questions for a total of 100 points. Some questions are worth 2 points, some are worth 3 points. If x represents the number of 2-point questions and y represents the number of 3-point questions, which system of equations could be used to determine the number of 2-point questions and the number of 3-point questions? So that might sound kind of confusing. So we're going to need to boil this down into a couple of different things. So we have 2 equations on each answer choice. And what we're doing is we have a total number of questions. So this is talking about number of questions. And then we also have all these things about points. So we're going to have an equation talking about points. How much is something worth? So we're going to go through and we're going to find all of our points. We have 2 points and we have 3 points. And it says that x represents the number of 2-point questions. So that means 2 needs to go with x. So I see 2 with x, 2 with x, 2 is with y, so that's not right. 2 is with y, so that's not right. So if we can just go match, we can eliminate some of our choices because they're not matching the correct things. Y represents the number of 3-point questions, so that's why the y is with the 3. And now the last part of this equation, again, we're looking at points. We're looking at points, 2 points, 3 points, and 100 points. So that means 2, 3, and 100 all need to be in the same equation. So 2, 3, and 100, 2, 3, and 25. So this is talking about points, and then number of questions. So B is now incorrect also. Your answer's got to be A. This bottom equation is talking to you about points. And the top question is just counting the number of questions. So it's adding your 2-point and 3-point questions to get your total number of questions. Answer choice A is correct. The graph below illustrates snowballs made per minute between Anna and Elsa. And we have a graph. What is the rate of change of number of snowballs with respect to the number of minutes that have passed for Elsa? So what we need to do is we need to focus on Elsa. And Elsa is the solid line. So this is going to be her right here. So we're going to focus on rate of change. Rate of change is just another way to say slope. So when we count slope, we're going to count rise over run. So we need to look at her line, and we're going to find some good points for her. So let's see. This one's a good point because it goes through the corner of the squares. As I follow the line up, the next good point that I have is this one right here. And just like before, we cannot just count boxes because we're going from 2 up to 12. So how far is it when we go up from a 2 to a 12? We're adding 10. So the rise is going to be up 10. And again, we're not just counting boxes because each box is worth 2. So if you want to count one box at a time, you're not counting by ones, you're counting by twos. 2, 4, 6, 8, 10. And again, I got that by saying 12 minus 2, or counting 2 at a time. To go sideways, again, we're starting off here at 0, and we're going over to 2. So how far is it from a 0 to a 2? It's going to be 2. We can also count by ones when we go sideways, and so we'll go 1, 2 that way. This time you can count each box because we're counting by ones. 10 over 2 reduces. If you don't want to reduce it, you can go type this into Desmos and hit that button that looks like a box, a line, and another box in that blue section. I'm going to reduce these by hand because I noticed that both of those numbers can be divided by 2. My answer is 5 over 1, and 5 divided by 1 is just 5. So what is the rate of change? Number of snowballs with respect to the minutes. 5 snowballs per minute. Question number 14, use the graph above of Anna and Elsa making snowballs to write a linear equation representing the number of snowballs y made by Elsa in x minutes. We already found the slope, So we can actually already go ahead and get this started. Y equals 5x plus, and then we have this b number. This b number right here, remember, is talking about y-intercepts. So the y-intercept, we have a whole lot of stuff going on over there. So I'm going to get rid of some of that. The y-intercept, where does Elsa's line cross? It crosses over here at 2. So y equals 5x plus 2.